Hello and welcome to episode 24 of Prime Puzzles. Let's get to it. 38 fruits, apples, oranges, plums, and guavas are distributed among 4 people, A, B, C, and D. Each one gets a minimum of 1 fruit of each type and maximum of 4 fruits of each type. There are 12 apples. There are 2 females, each of whom has the highest number of fruits. D, who has 3 plums, has 5 fruits less than the person who has the highest number of fruits. A has 4 apples and 4 plums and does not have the lowest number of fruits. B has an equal number of apples, oranges, and guavas only. C has an equal number of oranges, guavas, and plums only. None of the friends has exactly the same composition of all fruits as any other friend. Okay. Let's capture this information. I have A, I have B, I have C, and I have D. Additionally, I have to record which sort of fruits do they have. I have apples, oranges, plums, guava, and finally the total. We also had there are 12 apples. So there are 12 apples. This is recorded. There are 2 females, each of whom has the highest number of fruits. So of these 4 people, 2 people have X and X, which is maximum number of fruits. Okay. D, who has 3 plums, he has 3 plums, has 5 fruits less than the person who has the highest number of fruits. So the number of fruits with D is X minus 5. This is also guaranteed. Okay. A has 4 apples and 4 plums. 4 apples, 4 plums, and does not have the lowest number of fruits. A is not min. Okay, A is not min. B has an equal number of apples, oranges, and guavas only. So apples, oranges, and guavas is identical for B. This is done. C has an equal number of oranges, guavas, and plums only. Oranges, guavas, and plums is identical for C. None of the friends has exactly the same composition of all fruits as any other friend. Okay. I'm saying the 2 people who have got max are X, then D is X minus 5, and let the last person, the 4th person, let him have Y fruits. Altogether, should I get 3x plus y should be equal to 43? 3x plus y should be equal to 43. X plus x plus x, 3x minus 5 goes to the other side. We have a total of 38 fruits. We have a total of 38 fruits. Okay. Now see, wonderful thing. This is the count of fruits that D has. This is the count of fruits that D has. If D has 6 fruits, if D has 6 fruits, how I'm arriving at this 6 is minimum count of fruits with D has to be 6, because he will have at least 1 apple, he will have at least 1 orange, and he will have at least 1 guava. So if the minimum count of fruits with D is 6, X minus 5 is 6, so then in that case, X will be equal to 11. So Y will be equal to 10. We have one possible case, X and Y. Another case, if X is 7, X minus 5 is 7, minimum, the second lowest count of fruits with D can be 7, in which case X would be equal to 12, Y would be equal to 7. Okay. Another case, if D was equal to 8, in that case, X would be equal to 13 and Y would be equal to 4. We don't need to check any more cases. Because we know the lowest number of fruits with any friend has to be at least 4, because he has to get 1 fruit of each variant. So there will not be any more cases apart from this. Now looking at A, I'm checking this last case where the split of fruits with the 4 friends is 13, 13, 8, and 4. 8 and 4. Can A be the person who has received 4? No, it cannot be A because he already has 8 fruits. Can B be the person who has received 4? No. If B has received 4, then in each box, in each of these cells, he would have received 1. And the instruction was B has an equal number of apples, oranges, and guavas only. So the count of plum has to be different. It cannot be 4. Similarly, for C, it cannot be 4. D, it cannot be 4, because if D was 4, can you see apples, oranges, and guavas? Only 1 fruit will get extra population. The other 2 would remain 0. So nobody can receive 4 based on the information given. So this last case is definitely ruled out. Let's go to the other case where we have 12, 12, 7, and 7. 12, 12, 7, and 7. Okay. I'm just checking with a case. If it was 7, if this was 7, A would have to be 12, compulsorily 12. A would have to be compulsorily 12. Now between B and C, one of them has to be 12. So if this is 12, let's say B was 12. If B was 12, the only way you can have 3A or 3 variables being same and the other one being different, and yet you're reaching a summation of 12, would be if you have 2, 2, 2, and 6, but this would be a violation of the condition that any friend can have maximum 4 fruits of each type. So this is not possible. So we can't have 2, 2, 2, 6. If we want to have 3, 3, 3, then plums would also become same. This would be a violation that B has an equal number of apples, oranges, and guavas only. Now plums would also become equal. That is not possible. Can we have 4, 4, and 4? Of course not. Because if we had 4, 4, and 4, then plums would become 0. Can you see the second 12 cannot be placed with B? The second 12 cannot be placed with B. Similarly, can you also see the second 12 cannot be placed with C? So we are able to fix the first 12. We are able to fix a 7, but the second 12 gives me a problem. I cannot fix a 12 anywhere, which means even this case is impossible. So the case that we have for certain, is the 4 friends having count of fruits as 11, 11, 10, and 6. This is certain. Okay. If this is certain, I'm getting rid of these writings. If this is certain, we know that D has 6 fruits. This is guaranteed. If D has 6 fruits, he has 1 apple, 1 orange, and 1 guava. This is also certain. The next thing we know is, now I'm checking because the next person about whom I have a lot of information is A. Can A have 10 fruits? If A has 10 fruits, he would have 1 fruit here, 1 fruit here. He would have 1 fruit here and 1 fruit here. Okay. I should not be writing this with a black pen because this is a case that I'm checking. I'm going with 10, 1, and 1. Okay. Now looking at apples. One of these two people, if this has 10, these two would have 11. And the only way 11 can be reached, wherein all the numbers associated are within the range 1 to 4, 1 fruit or 4 fruits of each type, would be 3, 3, 3, and 2. Similarly, 3, 3, 3, and 2. This is the only possibility that would work for 11. You cannot have 4, 4, 4. You cannot have 2, 2, 2. This is the only possibility that works. But right now there is a violation in the total count of apples. Right now there is a violation in total count of apples, because according to this 3, 3, 3, 2 distribution, the count of apples that we are getting is 10, but we had the certain information that the count of apples has to be 12. So this is unacceptable, which means the starting point, the assumption starting point, wherein A had received 10 fruits is faulty one. No, A cannot receive 10 fruits. Let us then check. Okay, I now know A has not received 10, A has not received 6, so A has definitely received 11. A has definitely received 11. So now the next case that I'm checking is, let's say C received 11 fruits. If C received 11 fruits, then the only way it is possible is again 3, 3, 3, 2. This is the only way it is possible. And in this case, D will receive 10 fruits. Now look at the column for apples. 4, 2, and 1. 7 fruits have been received by 7 apples have already been allocated. Now B will have to get 5 apples, but this is impossible. Nobody can receive more than 4 fruits, which would mean my starting point that C has received 11 fruits is also faulty. I cannot work with that. Then I have to work my way forward. I now know for certain B has received 11 fruits, and the distribution is 3, 3, 3, and 2. And C has received 10 fruits. Now for apples column, this is 4, 4, 4, 3, 1, total 12. This is guaranteed. Now B is 2, 2. This much we are certain of. But right now, there are 2 cells empty. The number of oranges received by A and the number of guavas received by A. It could either be 1 or 2. It could be 2 or 1. The number of plums that are given out to all the 4 friends in total, that is certain. 11 plums were given out. But number of oranges given out could be 7 or 8. Correspondingly, number of guavas given out could be 8 or 7. And now we have all the information that we can potentially derive from this set. Let's get to the individual questions. The females together had how many more fruits than the males had together? This is the group of females, highest ones, 22. This is the group of males. So 22 minus 16. The answer to the first question is 6. What was the total number of plums? Total number of plums was 11. So answer to this question is 11. Which of the following pairs is the group of 2 females? The group of 2 females is A and B. Which of the following statements could be true? Could be true. A is a male. No, A has to be a female. B has more guavas than apples. This is faulty as per the question itself. This cannot be true. Next is the total number of, I'm just checking statement D. The total number of oranges is equal to the total number of guavas. No, when oranges are 7, guavas are 8. When oranges are 8, guavas are 7. So they cannot possibly be equal. Now by default, because A, B, D have been cancelled, of course it has to be C as the answer. And can you see the answer for C? In the second case, when there are 7 guavas and 8 oranges, C has 1 more guava than A. C has 2 guavas, A has 1 guava. Yes. Pay attention. The question is, which of the following statements could be true? Not is definitely true, could be true. With all that information, this question is complete. Hopefully, you learned something about counting slowly and taking care of all data points. Next set. The 18 boys and 18 girls in an IB school must study at least 1 and at most 2 out of 3 foreign languages: French, German, and Spanish. It is known that. This question reeks of Venn diagram. Let's go ahead and record it. I have French, German, and Spanish. 18 boys and 18 girls. Okay, so I should make 2 diagrams, one for boys and one for girls. French, German, and Spanish. This is for boys. This is for girls. Okay. First data point. A total of 20 students study exactly 2 of the 3 languages. Pay attention. You can study at most 2 out of 3 foreign languages. So can I say this is straight away out? This is anyway straight away out. A total of 12 students study exactly 2 of the 3 languages. So these regions together, the ones that I'm marking with a tick, they add up to 12. I'm just denoting it by the symbol tick. There are twice as many girls as boys who study both French and German. Okay. So if this is 2x, this is x. There are twice as many girls as boys who study both German and French. There are no students who study both French and Spanish. Okay. So this is 0 and this is 0 because there are no students, not boys and girls, no students. The ratio of boys to girls, studying both French and German, that ratio is 1:2, is the same as the ratio of boys to girls studying both German and Spanish. Okay, so even the ratio for this region and this region is 1:2. So let's say this was y and this was 2y. Also, we know all these ticks add up to 12. So effectively what I have is 3x plus 3y is equal to 12, or x plus y is equal to 4. Instead of writing y here, I can now happily edit it to this is x, this is 2x, this is 8 minus 2x, and this is 4 minus x based on the relationship we have identified. Okay. Up until 4th point we are done. The number of students studying both French and German is the same as the number of students studying both German and Spanish. Okay. The number of students studying both French and German is 3x is equal to the number of students studying both German and Spanish. Number of students studying German and Spanish is 12 minus 3x, or 6x is equal to 12. X is equal to 2. This is wonderful. I have 2 here. I have 2 here. I have 4 here. And I have 4 here. These numbers are identified. The ratio of boys to girls studying only French. The ratio of boys to girls studying only French is 2:1. So this is 2a. This is a. Okay. And the ratio of boys to girls studying only Spanish is 2:1. So this is 2b. This is b. Okay. The number of students studying only French is same as the number of students studying only German. Only French is 2a. Only French is 2a. Only German, the number of students studying only French is 3a. 3a. The number of students studying only French is 3a. 2a from here, a from here. The same as the number of students studying only German. Only German is how much? Total was 18 of 14 minus 2a minus 2b here. And here 14 minus, not 14, 8 gone here. So 10 minus a minus b. So 3a is equal to 24 minus 3a minus 3b, which gives me 6a plus 3b is equal to 24, or 2a plus b is equal to 8. I have got one relationship. 2a plus b is equal to 8. Okay. The number of girls studying only Spanish. The number of girls studying only Spanish is less than the number of girls studying only French. Number of girls studying only Spanish is less than the number of girls studying only French, or B is less than A. Oh, with this information, now I can have, see, because B cannot be 0. B cannot be 0 because ratio of boys to girls studying only Spanish is 2:1. The only possible case that fits here is 2 and 3. There is no other possible solution for A and B and anywhere else. A and B can only take on value of 3 and 2 because 2A plus B is 8. B has to be greater than 0. B has to be less than A. The only solution set that fits is 3 and 2. So this is 4. This is 6. So we are left with 4 here. Let me check. 6, 4, 4, 14 plus 4, 18. Yes, everything is fine. This will be 3. This will be 2. This will be 5. So 5 plus 4 plus 4 is 13. 13 plus 5 is 18. Yes, I have all the numbers in all the regions. Everything is uniquely identified. Let's get to individual questions. What is the ratio of number of boys to girls who study exactly one of the 3 languages? Boys who study exactly one of the 3 languages is 14. Girls who study exactly one of the 3 languages is 10. So 14 is to 10. The ratio will be 7:5. What is the ratio of number of boys studying French to the number of girls studying German? Number of boys studying French is 8. 6 plus 2. I thought I would be able to identify, but no, I have to check here also. Girls studying German is 5 plus 4 plus 4, 13. 8 is to 13. So option A has to be the answer. What proportion of boys study Spanish? Spanish is studied by 6 boys. So proportion wise, it has to be 6 by 18, or the answer will be 1 by 3. Option B. Last, what is the difference between the proportion of students who study German and the proportion of students who study Spanish? Students who study German is 8 here, and students who study German is 13 here. Now the students who study Spanish is 6 here, and students who study Spanish is 6 here. So effectively, I have 13 plus 8, 21 minus 12. I'm looking for 21 by 36 minus 12 by 36, which translates to 9 by 36, which translates to 1 by 4. So answer to the last question will be option D. That will be all for this episode. Hopefully you learned something. Okay, Janta, bye-bye.